8 minutes ago, a beam of light left a galaxy that is currently in the process of being torn apart, devoured, and erased by a much larger galaxy sitting right next to it. That light is only now landing on a mirror on Earth, and the telescope that caught it wasn't even supposed to be doing science yet. It was still being tested. What the Vera Rubin Observatory captured, almost by accident, during a routine calibration run, is something that professional astronomy had never confirmed before, even though the galaxy at the center of it has been photographed thousands of times over the last 2 centuries. A smaller galaxy, ripped open by gravity, its stars stretched into a glowing ribbon nearly 200,000 light-years long, wrapped around its killer like a wound that refuses to close. Subscribe right now, because what you're about to hear is not a simulation, not an artist's rendering, and not a theory. It is a real image, taken by a real telescope, of a real galaxy dying in real time, cosmically speaking. And once you understand what 8 minutes ago actually means on this scale, the rest of this story is going to hit very differently. Let's start with the telescope itself, because the telescope is almost as strange a character in this story as the galaxies are. The Vera Rubin Observatory sits on a mountaintop in Chile, and it carries the largest digital camera ever constructed. A machine so large and so sensitive that a single image from it would take hundreds of ultra-high-definition television screens to display at full resolution. This camera was built for one job: to photograph the entire visible southern sky over and over again every few nights for 10 straight years, cataloging everything that moves, flickers, explodes, or changes in the universe. But before that 10-year mission could officially begin, the observatory had to be tested. Engineers pointed the camera at a patch of sky that astronomers already knew extremely well, a dense cluster of galaxies so heavily studied that scientists assumed there was nothing left to find there. It was supposed to be a boring exercise. Point the camera at something familiar, check that the colors are right, check that the focus is sharp, check that the data pipeline behaves the way it should. Instead, buried inside that boring calibration image, something was staring back that nobody expected. A pale, impossibly long streak of light stretching out from one of the galaxies like a scar. And the moment scientists looked closer, they realized they weren't looking at noise, or a smudge, or an artifact of the camera. They were looking at a crime scene. The galaxy under attack is a spiral galaxy roughly comparable in size to our own Milky Way, sitting inside one of the most crowded and most photographed regions of the night sky. For generations, professional astronomers assumed they understood this galaxy completely. It had been cataloged in the 18th century. It had been imaged by dozens of major surveys. It was, by every reasonable definition, one of the most known objects in the sky. And yet, none of those surveys ever caught what Rubin caught in a single test image. That alone should stop you for a second. Think about how many telescopes have pointed at this exact patch of sky. Think about how many astronomers, professional and amateur, have stared at photographs of this galaxy over the past 200 years. None of them saw the wound running through it, because the wound was simply too faint, too spread out, too easy for older instruments and older processing software to erase without anyone noticing. Here's the part that should genuinely unsettle you. What Rubin photographed is not a static, ancient leftover sitting quietly in the dark. It is the physical trace of an event that is, geologically and cosmologically speaking, still happening. A smaller companion galaxy wandered too close to its much larger neighbor at some point in the relatively recent cosmic past. And once that happened, its fate was already sealed. When a smaller galaxy falls toward a much larger one, gravity does not treat it fairly. The side of the smaller galaxy facing the giant gets pulled harder than the side facing away. That imbalance, called a tidal force, works on the smaller galaxy the way a hand slowly pulling taffy works on candy. It stretches, it thins. Eventually it doesn't hold together as a single object anymore. Its stars peel away one by one, smeared out along the path the galaxy was falling on, until the galaxy itself stops existing as a distinct thing and becomes something else entirely. A ribbon, a scar, a record of its own death written across the sky in starlight. That ribbon is what Rubin caught, stretching outward from its host galaxy across a staggering distance, easily longer than the entire width of our own Milky Way from edge to edge. If you tried to lay it across our galaxy, it would spill past both sides at once. And it isn't faint because it's small or unimportant. Researchers who studied the image estimated its total brightness at roughly 100 million times the light output of our sun. This thing is bright. It has simply been hiding in plain sight for as long as anyone has been pointing telescopes at that part of the sky. If you're only now realizing how close this destroyed galaxy's story is to our own galaxy's story, buckle in, because it gets stranger from here. Comment below with one word: cannibal. If this is already blowing your mind, because we haven't even gotten to the part where this dead galaxy might have permanently changed the galaxy that killed it. Here's where the story stops being simple. Astronomers studying the heart of the larger galaxy found something odd sitting right at its center, clear evidence of an intense, rapid burst of star formation that occurred only around 10 million years ago, which in cosmic terms is essentially yesterday. A starburst like that doesn't happen randomly. Something has to trigger it. Usually that something is a violent interaction with another galaxy, an encounter that disturbs huge reservoirs of gas and sends them funneling inward toward the galaxy's core, feeding its central black hole and igniting a firestorm of new star birth. The timing lines up almost perfectly with the infall of the smaller galaxy that became the stream, which means the smaller galaxy didn't just quietly die. It may have detonated something on its way down. It may have reshaped the very structure of the galaxy that consumed it, triggering a burst of creation at the exact moment it was being destroyed. In a strange, almost poetic way, the victim may have left a permanent mark on its killer as its final act. Now here's why professional scientists are genuinely losing their minds over this, beyond the raw drama of it. A structure like this ribbon isn't just a beautiful cosmic accident. It's a map. Every star inside that stream is still tracing the exact gravitational path the doomed galaxy followed as it fell inward, which means the shape, density, and spread of the stream encodes information about the invisible gravitational field it was falling through. And most of that gravitational field isn't made of stars, gas, or anything we can directly photograph. It's made of dark matter, the invisible substance that makes up the overwhelming majority of a galaxy's total mass, and that has never been directly detected by any instrument ever built. By studying exactly how this stream is stretched, clumped, or disturbed, scientists can essentially reverse engineer the shape of the invisible dark matter halo surrounding the larger galaxy. There are competing theories about how dark matter behaves at small scales, some predicting a smooth, uniform distribution, others predicting a lumpier, more irregular structure. A single, well-mapped stellar stream like this one could help settle part of that debate. And the scientists behind this discovery didn't just call it interesting. They called it the first of what they expect to be a treasure trove of similar structures still waiting to be found. If a dying galaxy can help settle one of the biggest open questions in modern physics, what else is hiding in the sky that we've simply never looked deeply enough to see? Keep watching, because this observatory is about to reveal something even closer to home, something that connects directly back to the galaxy you're sitting inside of right now. Here's the part that should really get under your skin. Our own galaxy has its own version of this exact story playing out right now, close enough that we can't even step outside to see it properly. A small companion galaxy has been orbiting the Milky Way for billions of years, repeatedly crashing through our galaxy's disk, and every single pass strips more of its stars away through the same tidal forces that destroyed the galaxy Rubin just photographed. Those stripped stars form a long, looping stream wrapped around our own galaxy, one that astronomers have spent years painstakingly mapping from the inside, star by star, because we are physically embedded within it and can't photograph it from a distance the way we can photograph someone else's. Research even suggests that repeated collisions from that companion galaxy triggered major episodes of star formation inside the Milky Way itself, the exact same phenomenon that appears to have happened inside the galaxy Rubin just caught. Which means what you just watched happen to another galaxy, 8 minutes and 55 million light years away, is essentially a mirror of what has been quietly happening to our own galaxy for billions of years. We're not watching a rare cosmic freak accident. We are watching our own history, replayed somewhere else, where we can finally see it from the outside. And that's genuinely the unsettling part. If this kind of galactic violence is common enough to be happening to us and to a neighboring galaxy at the same time, how many other galaxies out there are quietly being torn apart right now, hidden behind exactly the same faintness that hid this one for 2 centuries? The honest answer, according to the scientists themselves, is almost certainly a lot. And that's exactly what this observatory was built to finally reveal. Stick around, because the reason this discovery happened now, and not 50 years ago, and not even 5 years ago, comes down to one specific engineering problem that every previous telescope on Earth has struggled to solve. Detecting a structure like this stream isn't really about how sharp or zoomed in your telescope is. It's about something much harder, catching an extraordinarily faint, extraordinarily spread out smear of light against an almost equally faint background sky. A stellar stream isn't one bright object you can simply zoom in on. It's the combined, extremely dim glow of potentially millions of individual stars, each one far too faint to notice on its own, spread across a region of sky tens of thousands of times larger than a single point of light. To photograph something like that, you don't just need a big mirror. You need to collect enormous amounts of total light from that huge patch of sky. And then you need software clever enough not to accidentally erase that faint signal while cleaning up the image. That second part turns out to be the real challenge. Most standard image processing techniques are built and optimized to sharpen compact, bright objects, individual stars, individual galaxy cores, and in doing so, they routinely and unintentionally smooth away exactly the kind of large, faint, diffuse structures that stellar streams are made of. For 200 years, telescopes may have technically captured photons from streams like this one without anyone ever knowing, because the processing pipelines used to clean up those images were quietly deleting the evidence before a human ever laid eyes on it. This observatory's imaging pipeline was purpose-built from the ground up to preserve exactly that kind of faint, extended light instead of discarding it. And the fact that it managed to reveal a structure this dramatic during nothing more than a routine pre-launch calibration test, before its real 10-year mission had even officially started, is being treated by scientists as a genuine proof of concept. If the software works this well before the observatory has even begun its real job, imagine what happens once it spends the next decade returning to this same patch of sky every few nights, stacking image after image after image into an ever-deepening record of the universe. If you think that's the wildest part of this story, you're wrong, and the next detail is going to make you feel a little bit strange about backyard telescopes. Here's a footnote buried inside this discovery that almost nobody is talking about. Years before this multi-billion-dollar observatory ever pointed its camera at this patch of sky, amateur astronomer working with a small home telescope, nothing close to professional-grade equipment, actually captured faint evidence of this exact same stream. It wasn't officially confirmed. It wasn't widely followed up. It sat there, quietly correct, waiting years for a professional instrument powerful enough to prove that a person working from their own backyard had genuinely stumbled onto something real that the entire professional astronomical community had missed. That should tell you something important about how much of the universe is still hiding in plain sight, not in some impossibly distant, technically unreachable corner of space, but sitting right next to galaxies we have already photographed thousands of times, waiting for the right combination of depth, patience, and processing power to finally reveal it. And that's exactly why this discovery matters so much more than a single dramatic photo. The scientists who confirmed this stream didn't describe it as a rare, isolated find. They described it as the first confirmed member of what they expect to be an entire hidden population, tidal streams, shattered dwarf galaxies, faint shells of stars thrown outward during ancient collisions, scattered throughout this one cluster of galaxies alone, let alone the rest of the observable sky. Over its planned 10 years of operation, this observatory will return to the same regions of sky again and again, roughly every few nights, stacking deeper and deeper combined images with each pass. Structures currently too faint to detect at all will slowly emerge from the noise, one accumulated image at a time. Some of those structures won't even be static. They'll contain subtle clumps, gaps, and density changes that shift and evolve over months or years, changes that can only be caught by an instrument patient enough and consistent enough to keep coming back to the exact same target over and over across an entire decade. That is not something any previous survey has ever been capable of doing at this depth. This is the first time in the history of astronomy that a single instrument will systematically photograph the same enormous swath of sky this deeply, this many times, for this long. If discoveries like this can happen during a camera test before the real mission has even started, you have to ask yourself what happens once this observatory has 10 full years of accumulated data behind it. Comment treasure trove below if you think this is only the beginning, because that is the literal phrase the research team used to describe what they expect to find next. Step back for a moment and look at the bigger picture, because this single stream fits into something much larger than one galaxy's violent history. Modern cosmology describes the entire universe as something that builds itself upward, piece by piece, over billions of years. Galaxies are not born fully formed. They grow the same way almost everything in nature grows, by consuming smaller things. They pull in gas, they merge with other galaxies of similar size, and they slowly, methodically cannibalize smaller companion galaxies that wander too close, absorbing their stars, their mass, and sometimes even triggering entirely new generations of star formation in the process. Every single time this happens, it leaves behind physical evidence, tidal streams like the one this observatory just caught, shells of displaced stars flung outward during violent mergers, faint asymmetric halos shaped by the gravitational pull of long-vanished companions. These are not rare artifacts. According to the scientists who study them, they are the expected, ordinary fingerprints left behind by the normal process of galaxy growth. The only reason we haven't seen more of them until now is that almost all of them are extraordinarily faint, extraordinarily spread out, and until this observatory came online, almost impossible to reliably detect. One of the researchers behind this discovery described these streams as part of an invisible web of gravitational forces that has been quietly shaping the structure of the universe and shaping our own galaxy for our entire existence, without us ever being able to see it directly. We have been living inside that invisible web this whole time. Every planet, every star, every galaxy sitting inside a slow, continuous, billions of years long process of things being pulled together and torn apart. And almost none of it visible to human eyes or human telescopes until an instrument sensitive enough finally came along to catch it in the act. That is genuinely what makes this moment feel different from previous astronomical discoveries. This isn't a single lucky photograph of a single unusual galaxy. It's the first confirmed proof that an entire hidden layer of cosmic history, written in faint starlight around nearly every galaxy in the sky, is finally becoming visible for the first time in the history of human observation. And it happened before the real mission even started. If this discovery, made completely by accident during a camera test, is already rewriting what we thought we knew about a galaxy that has been photographed for 200 years, imagine what's waiting in the data. This observatory hasn't even collected yet. Over the next decade, this same instrument is going to point at thousands of other galaxies, cluster after cluster, region after region of the southern sky, using the exact same depth and the exact same patient, repeated imaging that revealed this stream almost by chance. Scientists involved in this research have already gone on record predicting that this single stream is almost certainly just the first of dozens, possibly hundreds, of similar hidden structures still waiting to be uncovered as more data accumulates. Every one of those future discoveries carries the same basic promise this one does: a chance to map invisible dark matter. Want a chance to reconstruct the violent, hidden history of how galaxies actually grow, and a chance to finally see, from the outside, the same slow process of gravitational destruction and creation that has been shaping our own galaxy for billions of years, while we sat inside it, unable to look back at ourselves. So here's the real question this discovery leaves behind. If a galaxy this famous, or this photographed, this thoroughly studied for 2 centuries, could still be hiding a secret this massive in plain sight, what does that tell you about everything else out there that we've simply never looked at closely enough, or patiently enough to notice? The universe has apparently been quietly rewriting its own history all around us, in plain view, waiting for someone or something patient enough to finally catch it in the act. Drop a comment right now telling me which part of this story actually got to you. The idea that a galaxy could be eaten alive and leave nothing behind but a ribbon of stolen light. The fact that this was sitting inside one of the most photographed patches of sky in astronomy for 200 years without anyone noticing. The amateur astronomer who caught a hint of it years earlier with a backyard telescope. Or the fact that this observatory found it before its real 10-year mission had even officially begun. If you want to be here for every single discovery this telescope makes over the next decade, subscribe now, because based on how this one started, this is genuinely just the opening chapter of something much bigger. Thanks so much for watching all the way to the end. I'll see you in the next one.